All right. Last time we got some kind of level editing working. So we have this polygon that describes the scene, like the world, right? So we can jump on it with the player and stuff like that. And it also renders some grass, obviously, and some dirt here. So yeah, so last time we added this editor so that you can add new points, you can move points around, right? And this grass gets procedurally inserted here on top. And right now, the biggest problem is probably if I restart the game, everything gets reset. Because the initial this initial polygon is completely hard-coded. So what I want to do is have some way of saving this world state somehow into a file, so I can load it again. Because I really can't do any real editing right now, right? It's just gonna be discarded if I close the game. Yeah, so that's what I'm going to do now. So some way of saving polygons to a file. Okay. Let me think a bit about where we want to place that functionality. I mean, this world interface right now is basically owns the vertex data and the polygon data and all, like everything like that. So the world should probably be responsible for saving and loading this data from a file as well. So I guess we'll add some functions for that maybe. Yeah, I think that makes sense. So we'll have something like world world load maybe. And here maybe it's fine to just pass a file handle actually. We could pass the file name also, but no. And load and so load and save, or we could call it serialize and deserialize, right? Because it does. Yeah, we can call it serialize and deserialize. So serializing the world means encoding the internal data in some state that can later be deserialized, right? So serialize is basically save, and deserialize is loading the world again from a file. All right. So how should that look like? Let's see. Let's place those functions under world update. Just like in the header, same order. Okay. So I guess it might make sense to implement the saving first, right? Probably. So we have some data to work with, right? Yes. Alright, so right now we only have a single polygon in the world. And I think actually this will be pretty simple. So I think I'm wondering how we should do this in a nice way. I guess, so what do we actually need to save into the file? We have to save... well, right now we only have a single polygon, but in the future we're gonna have multiple ones, so we want to store how many polygons. That should be in the file, right? Or in the serialized stream, yeah. And each polygon has some number of yeah, every polygon. I wonder how I should type this. I mean, for right, so number of polygons, and then I guess each polygon should be here, right? So each polygon should have some kind of header, right? That contains the number of vertices in the polygon, and then the actual vertex data. Right, so when we deserialize this, we can just read this, right? And we know how many polygons to expect. And then we know that the next thing is a list of polygons, and every polygon block, let's say, first contains or tells us how many vertices are in that polygon, and we know how many vertices to read then. And we read all of those in. That feels simple. But how to do this? Maybe we actually... I don't think we need some custom file header or something right now, actually. For now. We can start with just writing out some fields manually here. Alright, so we want to know how many polygons. We want to store how many polygons we have in the world. And right now that's a single one, right? Wait, fprintf, no, fwrite. And this is the data to write the size of each element and how many elements. Okay. Right, so we write out the polygon count. And then for each polygon, well, we only have a single one now, so take this polygon, and the polygon has a vertex count. Yeah. Let's think. Yeah, we can write that directly, right? That's gonna be exactly the same like this, except for the polygon, and we can do this. Right, to prepare, because we're gonna loop over some polygons later, but we'll have each polygon, and we'll write out the vertex count. I think that's nicer. Okay, so we write out that, and then just write out literally just the vertex data. It's just a mem copy. We don't have to do anything special with it at all. Okay, so first of all, we just assert that this stuff actually got written. I like to have at least some kind of error checking for these values, right? It's just an assert, but we'll at least know if something's wrong. We could return an error here, but whatever. Okay, so how many vertices? We will know that. We'll just write out vertex count number of vertices, right? And every vertex position is a vector 2, right? Right. That's it, right? That's literally everything. Yeah, that's literally it. Okay, that was easier than I expected. So now we can kind of copy paste this. It will be a bit different, but instead of writing now, we'll just read from the file, right? And is that the same signature? We want to read into this polygon count, and the size of each element is the same uint. We read a single one, right? All right. So now, okay. So we're gonna assert that the polygon count is 1, just to prepare for the future, right? Alright, so we have the polygon now. That cannot be const now because we're actually gonna fill out these values, right? So that's gonna be the same. We read the number of vertices, right, into this vertex count, and then we read the vertex position data. That was simple. And I don't want to take the address of this actually because it's already an address, right? I think you actually, if you do use the address operator on a static array, it actually gives you the same one, right? I'm not sure, but this should be fine. Okay, that was very easy. So I guess let's add this logic. And I wonder when should we do the saving? I guess Control S, right? I can look for a Control S key press, maybe. So let's look for that event. So we have a key press. We look for a key press event here. So let's check if we press down Control, then we are holding Control. And we should also check for when we release it. If we release Control, we are not holding Control anymore. Okay, that was easy. And then we'll check. I think we have an S key. Yeah, S key. So if we do that, hit Control S, then I guess we'll just serialize the world, right? Oh, I think I like actually putting the file first. because it's kind of an output, right? It's kind of an output, and I like having the outputs as the first argument. But oh, that gets a bit weird here. Like I obviously want the same one, right? Okay, I don't care that much. All right, so. Let's call this, I guess, world dot bin, maybe. that is fine. All right, and after we serialize the world, we just close this file. That is superb. Maybe it should be in some subdirectory here, actually. Maybe in content or whatever. Whatever. We can try, I guess. When the game is started, I think that's the only point where we actually want to load this file is on startup. So I can do it right after the world is created, right? So then we deserialize the world. And in this case, the file might be null, right? If we don't have anything saved yet. Yeah. So we have to check that. Yeah. And then if the file doesn't, if there's no save file yet, we'll just use this default data, right? Right. Let's see what happens. I need stud.io. Wait, what? I have stud.io. Okay, in the header. Because of this, of course. Of course. All right. I can do some editing here, I guess. Doing some editing. All right, and let's click Ctrl S. Failed. World.c 401. Right, obviously this assert is wrong now because we actually want to write out more elements than one. All right. Why do we have a world? It's empty. All right, I create. Okay. We cannot load an empty world. Okay. Alright, Control S, and it did not crash this time. That's good. Let's see what the file looks like. Looks fine, right? This is this is the number of polygons, which is 1, and the polygon has apparently 7 vertices. Right. So what if I add a new vertex and I click save? Then we have 8 vertices. All right. Oh, that seems to have worked. All right. So if I save again and close and start again, it loaded my save file properly. Okay. Cool. Cool. So now this is persistent. That's nice. Okay, so I save that and close and go in. Yeah, yep. It loads my world properly. That was extremely easy. I don't know why that would be so hard, but this is the whole thingy, right? Okay, so that's done. I think I need some more complex editing modes, maybe. Right now I can just move. I can only move vertices around, and I can add new ones. I probably want to be able to delete some vertices. I could try adding that. No. Oh. We have 15 vertices. That's what the F means, right? Alright. That was too easy, almost. Like, this is the diff, right? And maybe I should include the world in the repository. Yeah, that's fine. I do want to put it in a subdirectory though. I can do that later. So world serialization. Okay, that's done. Now what? I guess I could try adding, making it possible to delete some vertices, maybe. Maybe. Okay, so if I wanted to do that, I guess I could do something like if I press the delete key while dragging a vertex or holding a vertex, I guess I could delete that. That feels like a good key key mapping. Right. So in the editor, we have to look for that. Do we look for any key presses right now? Yeah, control. Do I have delete in here? No, I don't. Let's add that. I wonder if I should call it delete or del. No, delete. I already called control, alright. So what could that be? Delete. Okay, that's good. Nice name. X11. Rub out. What the fuck is that? Rub out. The rub out key. All right. So that's that. So if we press delete, right, so the way we know if we are currently dragging some vertex, right, is if this edit polygon, right, if that's not null, that means we are editing a polygon. Editing means dragging around the vertex or whatever. So to actually delete a point should be pretty easy. We already do this in the triangulation algorithm. We just have to move elements forward, right? Every element that's behind the point that we actually want to remove, we just move those forward in the array. Right. So we have this edit vertex, which is the index of the vertex that we are dragging, and if that's the vertex we want to delete, then I think we want to start iterating from this one, right? And we go until the end, or one less than the end. Let's see. It shouldn't matter really. Right. The way I did it before was like this, right? And we should probably check if we only have a single triangle left. We do not want to delete any vertex because then everything fails, right? A triangle is the most simple polygon in 2 dimensions. Right, so if we have more than 3 vertices, then we can delete one of them. Okay, so we decrease the vertex count, right? Yeah, go through every vertex, and we just have to move all the data forwards one step. Like that. I think that should be it. the fuck did I do? What? Like, how the fuck did I... Jesus, okay. So... Let's try. I am dragging this, I'm clicking delete. Oh. Right, okay, so it did work, it seems like, except... I guess now when I actually deleted this vertex, I want to stop... I want to stop editing, right? So I just marked this as null again. That works. That works. Bye bye vertices. Yeah, I can't delete no more. Can't delete no more. All right. Cool. All right. I want some zooming in the editor as well. The game probably shouldn't have zooming on the scroll wheel. Let's try to do that. So let's just steal this code. It should basically be identical because the camera is defined in this exact same way. We set the height of the camera, right? That's nice. And it works with zooming, or it works with, like if I hold down and zoom, it works fine with moving around, which is nice. Okay, well, except for if I don't move the mouse. Until I move the mouse, it... Okay. But that's nice, that's nice. Nice, very nice, okay. So I can probably remove that from the game right now, because I only had that in the game because I wanted to be able to zoom, but now I have the editor, so I don't really need that. Bye bye zooming code. Okay, nice, nice, nice. So I feel like it should be more zoomed in. I'm unsure. I don't even know what the game is gonna be yet, right? So, what's next? What's next? Now what? Now what? I feel like it would be cool to get some It would be cool to have some parallax background, I feel like. And I'm wondering if I also want that. Do I want that also to be defined by polygons in this way? And do I want to edit the background in the same way? Is the question. I feel like that would be cool. And I do wonder how that's gonna work. Since the movement of the background is like scaled down, right? I feel like it should be possible to make nice. I would also like to make some more interesting grass here. But I'm not sure how, really. I could try adding anti-aliasing also. But that's not so fun, I feel like. And that might complicate some effects later, actually. So let's skip that. I could look into fixing my collision detection, maybe. So I can walk up this slope. Maybe I could do some... I could make some cool effect when I walk through the grass, maybe. I could make it bend. Yeah, let's try something like that. Let's try something like that. So I want some kind of vector field, right? So I want some kind of vector field, and yes. Okay, so we can do all of that on the CPU right now. That should be safe. So I want some kind of a grid. Some vector, some grid of vectors, right? Some vector field that represents how far I want to push something. So I imagine I want to like inject the player into that, the velocity of the player into that, and then have it like dissipate over time, right? I think that should be enough. So if the player walks to the right, it injects a bunch of vectors to the right into that field. I feel like that should be a nice first experiment, right? So I guess that would be considered wind, maybe. We can call it wind. At least I will make a wind .h. All right. I will call it wind, because I imagine like the player walking and he's basically, well, it's gonna be some kind of simulation. I'll call it wind. I will call it wind. Whatever. Okay. So we'll add the usual functions, create, and we most likely want the Vulkan interface here for uploading stuff to the GPU and creating textures, right? So we want to create the wind, pass the Vulkan interface into that, and we want to be able to destroy the wind. Maybe I can call this wind grid. Maybe I can call it wind grid. Does maybe force grid. No, let's call it wind. Let's call it wind. But it's not really wind. But it will look like wind. All right. Let's implement that stuff. And let's also add an update function. I really have to figure out all this time stepping stuff. Because I need a fixed time step. Right now, it's just updating every frame, which is frame rate dependent, right? So, and that's really difficult for physics simulations and stuff like that. Ooh. Okay, so we need that, and we can take the delta time here. Right, so allocate this thingy. Size of wind. And we should implement this, obviously. Right, and so what should we actually have here? I want some kind of vector field. Right. So for now, let's call it wind grid. So we'll have the wind grid size. No. Resolution. I think that's fine. And we can try with something like something simple, I guess. 64. Let's say 64. Right, small and nice. Okay. What is that even? That's like 256 cells in total, right? I think so. So that will be the cell count. Will be the resolution times the resolution. I think that's 256. Okay, whatever. So we will store the vector field. Include types to get the vector type. Okay, so let's call it the grid velocity. All right. Right, and as a very simple first step, well, let's start by just we are zero allocating this, zero initializing it, so that's fine. The initial state I think should be 0, right? And let's just implement this function as wind, not window, brain. Alright, so in each update, in each tick, we want to go through every cell. And just I think I just want to decrease this by some amount, right? So let's say we decrease it by 5%, right? Every frame. And right now we have a lot of frames per second, so this might be too fast, but we'll see. Right, wait. Right, let's just do this. So that velocity, and we need to include our vector functions. So let's just scale the velocity, right, by 0.95. Yeah, I forgot we don't have operator overloading once again. Right, so that's it. Extremely simple. And now we need to upload that data to some texture on the GPU. Well, or not. We could also just make it a buffer. That is simpler to upload. You don't have to care about the row stride and stuff like that. Yeah, we can just make it a buffer. Okay, so we'll have the... We probably only need a single one, so let's call it grid buffer. And we need some memory for that. The grid buffer memory. And I think I have a helper to allocate the buffer. Yep. We get back the allocated memory for the buffer. Just pass in the Vulkan interface and the size. Yeah, so let's make that the grid buffer size. So that's gonna be the number of cells times the size of a single vector. And the usage will be transfer destination, since we'll be copying data into it from the CPU. And it will be storage buffer bit. Yep. Memory property, and we want it to be device local, so on the GPU. Yes. I should start calling this VK. I'm tired of typing. So right, I have to store the Vulkan interface for later. I am gonna call that VK. Like, what else could VK possibly mean, right? Oh shit. So wind VK is Vulkan, right? Okay, so we save that for later. Device. and free the memory. Right, so after we update the simulation here, we have to upload the data to the GPU buffer. Right, and to do this, we actually need a staging buffer, it's called, which is some buffer in normal RAM that's visible to the GPU, right? And we do this in a bunch of places, so we have some kind of common, we have a shared place here, where every like subsystem allocates their own staging memory. So we'll make a function like that for the wind also. And let's see what this signature is. Right. Well, let's look at the scene actually, because we need to upload every frame. So we need to double buffer it, or triple. I don't remember how many frames we have in flight. And we do that in the scene here for the draw calls. Stuff like that. Right. So we have this separate struct, yeah, okay, sure. Sure, and we have the frame count, sure, okay. So let's just add this function to the wind. Alright, so in the wind, we have to know about the concept of frames, because when we have this staging memory, so we basically need to copy our grid into RAM first, in a special place in the RAM, yeah, that the GPU can access, well, that the driver can access, I guess. And it will then copy from this memory into up to the actual GPU, into the VRAM. And the problem here is that when we copy this memory, it's an asynchronous operation, right? We just tell the GPU to copy it, but it doesn't happen immediately after we tell it to, right? The GPU takes some time to process these commands and so on. So we actually need to double buffer this, because we can't like fill this memory and overwrite it the next frame, because the next frame on the CPU doesn't necessarily mean that the GPU is done copying the memory we filled out the previous frame. So we'll have the concept of a wind frame, and each one of these frames is going to have its own staging buffer. And it's going to also have staging memory, which is the actual memory location that's visible to the GPU driver, right? Or the GPU. I don't know exactly how it works, right? If the GPU itself has access to this somehow, like, but I think it's technically just a driver that does all of this copying, right? Because all the GPU knows is PCI, right? That's the only interface we have for communicating with the GPU. So we'll have some frames, and we have this frame count, which is defined somewhere, common maybe. Yep, and that's how many frames we have in flight at the same time. number of frames that we have queued up, right? Simultaneously. So we have those. And now when we allocate staging memory, we just call this. I can look at what this signature looks like from here. Right, so the frame is a staging buffer plus the staging buffer and the staging memory. And all we're gonna do with this memory is to transfer from it, right? So transfer source, right? Wind. Let's call it wind staging. Right, and the size of this is gonna be exactly the size of the grid buffer size. Right, we're copying the whole thing every frame. Okay, makes sense. So in here, we need a couple of things here. I think we have this render context, which contains things that might be useful, or that will be useful, actually. So we'll take this, because we need... What do we need? We need this staging memory context, basically. And we need to know the frame index, right? We need to know the frame index in order to pick out the correct frame. So that's the render context. Right, so now the frame index, and this is the... I think this is the, like, total... Current frame... I think current frame is just... Okay, it is, like, clamped, so it's... Right, okay. It is wrapped. So... let's create this wind now. So we have the wind. Right, we have to include that. Include the wind. Yep. So we don't have to do that. Like, okay. So we have this wind frame, right? So we know that's gonna be the current frame. The one that the GPU is currently not rendering. Right. And we have the staging memory, and all we wanted to do, mem copy. Where is that? It's in string, right? Mem copy. So we want to copy into this staging memory the current state of the simulation, right? These velocities. Makes sense, and we want to copy the whole thing, and that's gonna be wind grid buffer size. Okay, that's it. And we have to make sure that all of the CPU caches are flushed, so that this data is actually in system memory. So we have this API to do that. And that's also in the render context. It's already a pointer, yeah, like that. And we have to send in the memory address we want to flush and this size. So that's the same parameters here. And that's gonna be flushed at the end of the frame before we submit the command buffer to the GPU. All right. And now we can also just copy the buffer, and I have this in a bunch of places already. Let's copy that. Right, so this is gonna be the actual copying from RAM to VRAM. And this is gonna be the same size everywhere, and there's not gonna be any offset needed, right? No. So we're gonna copy from the staging buffer into the grid buffer. Right. That's it, I think. I think so. I think so. All right, so let's add this update call somewhere. We should probably have it here. We do a bunch of other copying here, so let's do it here because we need this barrier later. So that looks fine. That looks fine. Still. So pass the wind here, pass the render context, and the delta time. Okay, we're not actually using the delta time, I just realized, but whatever. We could actually... So we have a grid resolution, right? But each cell is gonna have... This grid is gonna exist in the world, right? So each grid cell is gonna have some size also. So let's say the grid cell size, and for now let's make that 0.5. All right, because I wanted to debug draw this grid. Right, and we can actually pretty easily just draw the velocities also. So let's do it like this. So let's go through the X direction first. We have the grid resolution, yeah, +1, and draw debug I need to include the debug renderer. Debug renderer. Draw debug line. And that's going to go from, let's see, x times the cell size. Yeah, and y for now that's gonna be 0. Probably have some origin later. Let's say that the color is just white. Yeah, let's make it white. Not that bright though. Like that. All right. And we want to draw the whole height. So what would the height be? It would be the resolution times the size of each cell, right? Yes. Yeah. Let's see how that looks. Okay. We have some grid here. Looks fine. Looks fine. And let's draw the other direction as well. So this is gonna be just swapped simply. Like that, and I want to make it a bit less bright even. Because it was a bit jarring to look at. Let's do it like that. Alright, so we have the grid. We should probably there should probably be some origin to this one. There should probably be an origin. Because I want it to be offset a bit, so it actually covers our level. Our level. Right. Let's first add debug drawing for these for the actual velocities. So, yeah, read the velocity, right, and we can figure out the x and y coordinates trivially. We know the grid resolution, right? I think that's that. I think that's that. So we want to figure out the center of the cell, which is just x times the cell size, right? So that's the left, and we just add half of the cell size to that. That makes sense, right? And it's gonna be the same in the y, on the y-axis. Right. So let's we can start by just drawing a point at the center, see if it works. Center X. A red point. That works. And I think the actual debug drawing that we want, right, is to draw a line from this center. A line from this center towards where the velocity is pushing it. Like that. Like that. Yes. Yes, yes. Alright, now though the problem is that we don't have any velocity data to actually draw, so right now, yeah, there's nothing to see here. Right, so what I'm thinking is that we want to somehow inject some velocities into this grid, right? And this player here, I think we should inject the velocity of the player. So how do I want to do that? Well, the player is inside of the game, right? So I need some kind of API here. Some kind of API to inject velocities. And I guess what should that look like, right? We want to inject something into the wind. And yeah, what should the data be, I guess? What should that data look like? We can call it a wind injection, maybe. It's at least going to have... I think maybe it should actually be a bounding box of sorts. So let's say that we have a minimum and a maximum. Well, that's a bit ambiguous. Let's call it... axis line bounding box min and max, ABB min, and let's say that across that box there's where we want to inject this velocity, right? Right. Well, we could make it easier for ourselves. Let's just say that there's a position at which we want to inject some velocity. We can make it better later, maybe. Right. So we want to be able to inject this. And how should we do that? Should we just do that? Let's see. So finding the actual grid cell is very simple. I guess we should first bounce check it, maybe. So if the... Let's see. If the position is less than 0, right now at least, since the grid is at the origin. Let's say that, or if the y position is less than 0. And we also know the and if it's greater than, what would this value be? We know the wind grid resolution, right, and the wind grid cell size. I guess that's it, right? And the same for the y-axis. Then we just skip this. Otherwise, pos x. Okay, so it's very simple to figure out the actual grid cell index of this. I guess we just take the position and divide it by the cell size, right? That's it. So we know the grid x and y, and then we can figure out the index. Trivial also, we check the grid resolution. It's row major, right? Like that. And that's the actual cell index. And for now, we can just inject it directly here. So we have the velocity data for each cell. We just assign that to the velocity. That should be a very simple test to start off with. Right. So now, when we are updating the game, I guess the game should be the one actually injecting this. So the game has to somehow know about the wind system, right? So let's pass that into the create function.
You know, if it's happened to you, if you're listening to this and it's happened to you, then you'll understand what goes on. You're consumed in this.
And just keep it along. And then when we are, I guess we can just do this when we tick the game, right? So yeah, so let's just, should be easy. We have the player here, right? We can do it at the end here when everything is done. We can just inject into the wind. Wind injection. Right, so the position will be the position of the player. Do we have the player here? No, well, it's in the game. So the game has the player, and it has the position of the player, and it also has the velocity of the player. Like that, and I think something should happen now. Right. Yeah, we have to add the wind here now. All right, I have to include my vector types. All right. Okay, so there's still nothing being debugged drawn here. Maybe I can try. Maybe it's disappearing too quickly, or maybe the velocity is too low. Guess we can first try scaling this by some arbitrary value to see if there's something going on. Oh yeah, okay. So there's some value being pushed into this grid, right? It's just dissipating very, very fast. Yeah. Oh, I should really make this like delta time independent. Okay. So that's something. it seems to be very little in the X direction, but I guess. Like, does the player actually have like X? Use the X velocity. I have to check that because when I move, when the player moves, yeah, I don't set the velocity right. What would happen if I actually did that? What would happen? Okay, let's restrict this to the y-axis actually. Because we only care about gravity. Okay, so we don't want to move the player with the velocity. Ah shit, wait. Well, let's... Okay, this is a bit scary, but should work. Okay, so the X velocity is like... It's not gonna be used for anything else than this. Okay, so I guess when we do this movement, we just assign the velocity to this. Yeah. Let's see. Okay, that looks better, right? All right. We should probably move this grid down to the left, so I can actually see if it's gonna have some effect. Because I want it to affect the grass movement, so yeah, it has to be pushed down. So we need, so we want some kind of origin. And that should just be a 2D vector, right? So we have the grid origin. And let's just set that grid origin when we create this object. Vec2. And that can be maybe -5, something like that. Alright, and now we gotta use this for everything. So yeah, when drawing the debug grid, we have to add the origin. .x. The y. Alright, so the center now should also be offsetted by the origin, like that, and now the debug drawing should work, yes. However, it's still injecting at the wrong position. Okay, because we only moved the debug drawing, obviously, so I think the best... The nicest solution is probably to just move this move this position to the origin, right? So just add the injection position to the origin. Yeah, so, well, in essence, the origin is negative, right? So it's gonna subtract it. Well, do we want that? Wait, no, no. We want to subtract, right? We want to subtract. I think so. So this position is now like in the local space of the grid, right? Unscaled, no. Okay, that looks fine. I can probably, as testing, actually, I can just normalize this. Well, what happens actually if... Okay, we can check that condition first, because if you try to inject a zero velocity, I think we can just skip that, right? That doesn't make sense. So check that condition. I guess we can do that in the same. Alright, so we check the bounds of the position and check that we're not injecting a zero velocity, because if we normalize a zero vector, that's trouble. Right, so we just normalize this and it should be good. All right. All right. It's only injecting at the feet now. I guess I should. Okay, I will change this. So it's better to inject some shape, right? So we will do a bounding box. We'll do a bounding box. So bounding box min and max. Right. So how to do that? So we need some. So we basically want to rasterize it, right? Basically, do conservative rasterization on this box. So yeah, okay, let's do it like this. We'll skip the bounds checking, at least in this way. We'll still check the velocity. That makes sense. But now, so we want to... we want some range. Like if we inject a bounding box into this grid, right? In this case, for example, we want to affect all of these 6 cells, right? So we want to check which cells this bounding box overlaps and inject the velocity into all of those. Right. That is pretty simple also. You basically just take this, because this will be the minimum of the bounding box and this will be the maximum value, right? So we just take this minimum value and floor it, convert it to an integer, and that's it. So we have the minimum divided by the cell size. Yeah, and just cast it to an integer, right? And for the max, I could use a floor f, but it's not needed because... Oh, maybe it is actually. Oh well, we at least have to include the math to get these math functions. So let's say we take the floor of this floating point value, right, and cast it to an int. Makes sense. And for the maximum one, we take the ceiling value and the max, obviously. Yeah. X and Y, yeah, seal. That's it. Okay, so now the only difference is that we should loop through this range, right? And I wanted to adjust this before because the minimum could now potentially be negative, right? And that is not good. So we'll just check that. If it's less than 0, we'll make it 0. Same for the y-axis. Right, so we want to loop through. We'll do the y first because it's a row major. So that's better cache coherency. So we start at the minimum cell and we want to go up to and including the maximum. Right. And then the exact same in the x direction. Like that. So right, we have to take the origin into account. Right, I guess we'll do that. I guess we'll just do that here. Like that. I feel like that's correct, right? Grid origin X, grid origin Y. Right, so this gives us the range of the cells that we should fill, right? Yeah, and we do this loop. Right, and now figuring out the index is exactly the same, and filling it is exactly the same. Okay, so let's see where we actually called this from the game, and does the player have? Do we have like a? Yeah, the player has a size. All right, the player has a size. So the minimum should be. Let's make it. Let's do each axis separately. So we'll have the position minus half of the size. Okay. And the max should be just plus. Makes sense. And in the player, like this, okay, this position is actually like the position of the feet. So the minimum y should be exactly at the feet, so that should be unmodified. And the maximum should just be the size. The maximum should be the size. Right. Oh, did I build it? No. Okay, that's cool. It looks like a lot, though. Like it's... And what's up here? Like, why am I not... why is it not injecting? Is it because of the collision code? But I thought that shouldn't be modifying the X component. The X component is only modified in this movement code, right? That's strange. Oh, wait. I think I know. I got this logic wrong, right? We want to check if both, if the whole vector is 0, right? Right. Okay, that's working. Okay, and I already wrote the code to upload this into a GPU buffer, so I assume that that buffer is gonna be working. So now I want to try to bind that and actually use it in the shader when drawing the world. So where is all that? That's here. So first step is to, I guess, actually bind it. So we have this world shader here, and this is the shader for these plants, these flowers, also this ground. So I want the flowers to kind of move with this velocity that the player is injecting here, right? That's in the grid. Okay. That should be pretty simple. I feel like I already have this wind movement, right? And it's gonna work, I guess, exactly the same, right? Right now I source it from this wind function, procedural wind, and I just have to sample. I guess I could do that. Yeah, I can do that here. So that's gonna be included in this wind. So I have the wind grid here. So yeah, we'll have to pass the position here also now. Well, now let's make a separate function actually. All right. So we have the vertex position, and we are going to need the origin of the grid here also in the shader. Where do I actually fill this right now? I fill this in the scene. Somewhere. Yeah, here. Okay, so I guess the question... might as well do this at the end, right? Well, I guess that doesn't really matter. I could yeah, I can just fill these in here. So okay, so we need some way of getting this grid buffer, right? So we'll do it the same way I've done in all other places. So we'll have this wind render info. Which will contain this buffer. So we'll call that the grid buffer, right? I think we called it the grid buffer. Yes. And I guess we can also just... we can just pass this this origin also. Let's do that, and then we can fill the constant buffer with that. Yeah, let's do that. Let's do that. Okay. So we want some way of want some function to get this. Wind. I think I call it like get render info, right? And we have the info out there, and we get the wind in here. Right, and filling this info is actually very simple. It's very simple. Just getting these and the grid origin. It's just the origin. Okay. Simple enough. And now we'll use that here when rendering. So first include the wind. Right, so we have the wind. We can do it up here, I think. Wind render info. Get render info. And yeah, let's pass the wind into the render context. I have to change this up at some point. Don't really like this. But it's fine for now. Okay, so where do I create the render context? Right here. Just pass the wind. Pass the wind. Pass the wind. So now we have that. And now when rendering the world, we just have to bind this wind buffer, right? Like that. And we also have to add this into the descriptor set layout. When we create that here, so we have a new buffer. All that is the same, right? Yes, all good. And also I will pass. So we had the frame uniform buffer, yeah. No, wait, the uniforms, right? That's the actual memory. That's the actual memory. Okay, so GPU types inside of these uniforms, I will just. I'm a bit unsure about padding here. But this should be fine. This is 4 elements, so that's should be all good. So we'll have the wind grid origin in here, right? And now the size should be 88, right? Yeah. Yes. And we'll set the origin using this wind info, right? The grid origin. Nice. Nice. So now we should be able to sample this. I wonder if I forgot something. No, so everything compiles still. So let's actually sample this grid now. So in order to do that, I guess we have the vertex position, and this is in world space, right? I can make a new function actually. So we'll make a sample wind grid with some position. Okay. Right. Vertex position, position XY. And we probably have to scale that down a bit. Preliminarily, okay. So we have to figure out the cell indices or the cell index that we want to sample depending on this position. And there's one thing that we're missing, right? We need to know the size of each grid cell. Yeah. So we should move this because that needs to be known by the shader. We'll just move that here. And I guess now I actually need this in here, right? So I should probably include these GPU types. Well, where are those actually? Those are in the shader folder, so I have to do that. Right. So we take the position. Well, let's do all components at once. So we'll take the position we have. We have to subtract the origin from that. So we have the wind grid origin. That should be. Is that everything? If we floor this value, right, that's essentially what's going to happen, right? We will floor this. Right, first we also have to now. Wait, should I divide it by? Yeah, wait. Right, all of this should be divided by the wind grid cell size. I think that's what I called it, right? Okay, so we know the grid position, so we can figure out the index by just right. We need to know the resolution as well. So let's move that as well into GPU types. Right. Like that. So that should be the cell index, right? We should probably check whether this is negative and stuff. But whatever. So we have the wind grid, and we want to load. We can do typed load. We want to load a float2, which is the vector from the cell index. Like that. I think that's it. And we do have some errors. Okay, right, because the vertex position is actually 3-dimensional. Okay, I have to. Okay, I have to multiply it by this animation factor, right? That looks pretty cool, actually. Pretty cool. That looks pretty cool. Okay, let me hide this debug drawing of the grid so we can see anything. I mean, it's really jumpy, right? It's really jumpy because when I'm injecting, I'm immediately changing the velocity. I have to do some better fluid dynamics or something. That's pretty cool as a first step thingy. I can try to scale it up a bit even to make the effect more drastic. Okay, so I need to I wonder how I should simulate this. Like, when I inject the velocity, I don't want to immediately change it, right? Maybe it's fine to kinda, I guess, just add to it. Let's try that. Man, everything is so I have to start doing things in like fixed time step intervals, because this is really difficult now to get looking good and consistent. But let's say, so instead of just replacing the velocity, let's just increment it, right? So let's just grab the velocity, and we want to add to it this normalized one, and let's scale this by some factor. We probably want less than that. I think that's a bit too much. So I guess I should probably I should normalize this afterwards also, probably. That should be even less. Like, even less. When it looks a bit. Wait. Oh, I am. Right, I don't want to normalize it, right? I want to just. I only want to limit the magnitude, right? So we have to check the length first. So if the length is greater than 1, then I will normalize it. Right, that makes sense. That makes sense. Well, is that still really? It's like too fast. Oh, I changed it up, right? Okay, that looks better. It's not as not as extreme, right? Not as jumpy. I like that, actually. I really like that effect. Looks cool. Looks cool. Now the only problem, I guess, is that the grid is finite, right? It's finite. So I would like if I walk inside outside of the grid area, right? It's nothing is happening, obviously, because the grid isn't covering this space, right? So it would be cool to have the grid be centered around some position, right? Most likely the player or the camera, right? Right. Maybe we could do some bilinear filtering. Actually, that could maybe improve the look a bit. And since I was lazy, I mean, I put this in a buffer because the uploading code is a lot more simple than having to care about texture memory layouts and stuff like that. So I will do that manually, and I even wonder if this is correct, right? Because we are truncating the float. Well, that is probably correct, right? However, if I wanted to now do bilinear filtering, God damn it! It would be easier to just have this in a texture, right? But uploading textures is annoying. It's a lot more involved than just uploading a buffer of data. Because reasons. And it would be hard to verify if this bilinear filtering would even be correct, right? Well, we can try. So, how do we need to change this? We obviously have to sample load from this grid 4 times, right? We need 4 values. So we need to know the cell indices of all 4 of those. So we can start with figuring out the top left cell index. So what has to change? What has to change in that case? We want to shift this Do we want to subtract 0.5 from it? I feel like that's what we want, right? Well, it's gonna be... Let me think. We should probably pull out this to some separate... so that's like the float grid pus, like, right? And we just... Right now we just truncate that, right? Because if we have this separate, then the fractional part of this value is basically the bilinear factors, right? Bilinear, let's call it that, factors. That should make sense, right? That makes sense, I think. Yeah, the only question is now, should we subtract from this? And I feel like we should, because we want the top left one, right? So we probably want to subtract from it. So that will be the yeah, grid post, and we get the cell index from that. And to get okay, so that's the top left cell. Well, we can just call it cell index. And instead, I guess we'll have some... we need 4 indices, right? 4 indices. So we'll have index 0, 0, which is just this top left. And we'll have 1, 0, which is the cell index plus 1. Right, makes sense. We moved to the right, and then we'll have the index 0, 1, where we just add the resolution, right? And we add the resolution plus 1 to get the bottom right index. Okay, so now we can sample. Now we can sample all of these 4 indices. So we'll have, yeah, let's call it V00, 0, and so on. So we'll use 0, 0 there, and just repeating this like that. Oh, I did it in reverse order, right? Okay, yeah, okay, sure. Let's do it like that. All right. I think that's the same order, right? Yeah. Okay. So we want to load those same indices. Okay. Now we have the 4 quadrants, right, of the bilinear sample, and let's first figure out the horizontal wait. Yeah, yeah, let's interpolate the x first. It doesn't really matter. It doesn't matter, literally. Okay, so x0 is the top, I guess. So we're gonna lerp between V00 at least, and V10. Yes, yes, and we're gonna interpolate with this bilinear factor, right? In the x. Okay, so and we have x1, which is going to be the same, but with 0, 1 and 1, 1. Okay, that should be it. And finally, we'll get the final interpolated value by lerping these two values with the bilinear factor, with a vertical bilinear factor. I really wonder how this is gonna look. I mean, it's hard to verify, right? It's hard to tell. It looks correct to me. So the only flowers that's moving inside of this grid that we're not injecting into, right, seems to be the flowers that are to the right, to the left of the pixel center, right? So that's, yeah, it seems to be working. It's the same here. Like the ones that are actually moving seem to be affected are the ones to the right of the pixel center there. So it seems like we got it working, and I feel like it looks better, but it might be placebo, right? Let's hide the grid so we can see it a bit better. I really like the look, actually. I also imagine I could like do a lot more with this also. Like I could move particle effects and stuff like that, right? And I can have more things injecting also into this grid, right? Like enemies, if there are enemies in the future in this game, or physics objects in general, right? Some stone rolling, a rolling stone. Okay, I think that looks cool. I think it does. I can't stop. I can't stop running in it. I can't stop. I could up the factor a bit, but that seems like the perfect magical number, right? 0.4. 0.4 seems to be the sweet spot. Like this is way too much, right? Definitely. That looks like, yeah, that looks weird. Looks weird as hell. Well, it definitely looks a bit weird here also, but like, yeah, I need to fix like fix this stretching. You can see that they're squishing, right? They are squishing together because they're using the world space vertex position to do the actual computations. So each part of this flower is like gets a different wind amount, right, to move. And I want to somehow, there should be some kind of pivot, right? So each vertex should have some pivot. I guess that could be like a relative index. I guess like starting at this vertex index. I guess it could say that like, okay, you move backwards some number of, or forwards, backwards or forwards some number of indices to get the pivot. Something like that. Because it's really noticeable here as well, like the flower petals are like stretching out. It's not, doesn't look that good. All right. Oh. I forgot I have a level editor. Save that. Saving is working, right? Yeah, collision is not, though. Extremely wonky. Right, I should probably fix. Oh Christ! Yeah, I should fix these leaks. Fix these object leaks. Someone's gotta do the boring stuff also. Okay, so gotta clean up the staging buffers also here, I guess. Okay, that's strange. Command buffer in use. Interesting. Oh well. Okay, so I have unnamed buffers. Maybe I can also fix that. Right, because I have this, I guess. Yeah, I have this create buffer call, and I should probably require a debug name when creating buffers with this function. I will do that later. So, right, we have to destroy these staging buffer as well for each frame, right? And I guess one problem is that we don't even destroy this this wind interface, right? Is there something else I forgot to destroy also? Yeah, I think. Well, this editor. Yeah, I forgot. So where do we destroy? Okay, I forgot that as well. Really. I guess I can do that here. Destroy the game and destroy the editor. Right, I think that's those are all objects, at least. Let's see if there's more. Okay, that's all. Good. Okay, I should commit this, I feel like. So, yes, yeah, we also added support for deleting vertices in edit mode. And we add the wind grid. I guess that's a good description. Right. This looks so good, honestly. I mean, except for... I really like the effect. Like... I really like the effect. And like... It's so little code also, like it's not even... It's really easy, but it would be cool to, I guess, make it like... Maybe a bit more... Yeah, I don't know, maybe the simulation is good enough, right? It's literally just... Where is my ticking? This is the whole simulation. Oh, Jesus Christ. So much shit. This is it. Very complicated. Okay, I like the debug rendering also. Maybe I could also... I can maybe... Maybe I can inject... I can scale down the injection on these like cells that aren't like fully covered, right? Wait, is this a... Why is it injecting... It's injecting too high up here. It's injecting too high up. Wait, is it also injecting? No, the X direction seems fine. What? Oh. Well, it's injecting. It's injecting too much. Okay, what's that about? What's that about? Right. Yeah, it should only be injecting into these two, right? But this one is there. Okay, so... Oh, maybe it actually shouldn't be... Should just be less than, I guess, because we do a seal. Right. Okay, that solved it. That solved it. Nice. Nice.
You see, my love is alive. It's like a seed that only needs the thought of you to grow.
Nice. Okay. Fix wind injection. Yes. All right. Can I do anything else? Anything fun? Well, there are some... There are some architectural changes I want to make, or some really... It's not even architecture, it's like... It's just... What's it called? X. That's what the cool kids call it these days, right? So like I have this render context, which I have added too much stuff in it, because there are some like fundamental things that you probably want in a lot of places, like this staging memory allocator, or not allocator, but staging memory context that's used for stuff. And the Vulkan context, I'm not sure if I have to pass that, but like yeah, the frame index, that's nice to have, right? Elapsed time, not so much. So the problem is, like, there's all this stuff. The render targets, maybe. However, there are these things like the model loader. That's not even alive right now, but whatever. So we have the world and the wind, right? And these things should not be here, I feel like, because this render context is even passed into the wind simulation, and that just feels wrong. So what I want to do instead, and like these are only used by the scene, so I should create a separate, I guess basically a scene render context, right? For these specific things that only the scene needs. Because the other render context, it should be more like low level, and like stuff that a bunch of systems might need. But like the world and the wind, and I guess like even the world and the wind. Why am I passing this? I mean, I can just... yeah, I should pass them. Because I could just pass them in when creating the scene, right? And the scene could hold on to these interfaces. But they're only used when drawing. So yeah, I can just pass them when drawing stuff. I feel like that's fine. Now I guess the question, because we also want this render context, right? Should I pass the render context inside of the scene render context? Or should I just pass both? These are life's biggest questions right here. And like, yeah, the debug render I can also just put here, right? Debug renderer. So I have the render context, and I guess I will have the scene render context. The SRC. Yeah, sure. I like this function formatting, actually. I feel like I think I like it. Maybe. Or maybe I should just strive for not having so many arguments, like, and how does it look now if I like have it on a single? Yeah, I mean, it is like a million times more parsable, right? Using your eyes. Yeah, let's do that. Oh, I already did it here. Okay, so now I assume this is will be a couple of places now that won't compile. Right. Well, obviously main, where I put all of these things. So be gone. Okay, so we have the scene draw here. So let's create this scene render context here. src, that feels a bit ambiguous. But alright. Train doesn't exist anymore. Right, so this is the call, I think. And we also put the debug renderer in here. That's not a pointer. Right. Alright. Copy paste. Mistake. Alright. So now there's some stuff moved, right? So the model loader is in the scene render context. The lapse time is in the scene render context. Debug renderer is in there. Okay. Compiles and runs. That's good. Good news. That felt good though. To refactor. Right, because now this, yeah, we can see the list here, I guess, of like the wind, for example. It takes in the render context, and like the wind was, there was a pointer to the wind in the render context. Like, yuck. And I feel like the render targets. Does anyone actually use this except for the scene? I don't think so. Okay. I will include it instead of forward declaring. All right. I'm gonna assume that the only one that's actually using the render targets is the scene. And I think I would like to keep it that way. Anyway, probably, most likely. I don't think I will regret moving it out, at least. Man, I mean, I should really start forward declaring structs instead of including everywhere. But okay, so we already include the render targets here. So let's add it Render targets. And can this be const or RT, right? Can probably be const. Right, and we can just search and replace this. Should be easy. SRC, like that. Right, and we have to pass that now. Pass the render targets. I call it RT. This one. Okay, that works. Yeah, okay, that feels a lot better. Right. Now what? Do I have more stuff that feels yucky in my code? Well, it would be cool to move well, basically everything to a fixed time step, right? Because like in the game I do use the delta time, right? I use the delta time, but it's like the actual delta time. It's the time it took to process the previous frame, right? Basically. And like doing physics using this variable delta time is not really reliable at all. So I should ideally have some kind of fixed time step, right? And I mean, most games have this, right? So something like maybe 30 FPS or 60 frames per second. Have the actual game logic and physics tick at that rate, right? And then when rendering, well, the first approach would be to just not care, right? So the game would literally, like, it would, maybe we can render like 100 FPS, but we would see the exact same game state, right? Every single frame. At least at 30 FPS. So, but you can kind of solve it. Like you can interpolate between these discrete time steps, right? When you are actually rendering. But as a first thing, like I don't have to care about that at all. So I wonder how if I want to do this on a high level, I probably do. So in my main loop, I have this delta time thingy, right? And let me think. Yeah, we should probably have some kind of global, like, let's call it tick rate, and let's specify that in hertz. So how many ticks per second? Let's start with 30, actually. I think that's good. And then the delta time will actually be a fixed value, right? So that will be 1 divided by the tick rate. Yeah, so that will be in seconds, right? We can do that in milliseconds, because I think my delta time right now is in milliseconds. So let's make that in milliseconds, actually. Yeah, let's do that. So we have some kind of delta time calculation here. So this delta time is the time since the previous frame. So we want we want to basically accumulate this, right? We want to have some kind of let's call it tick accumulator, maybe. So we want to accumulate this delta time in some kind of value. Let's put it by this delta timer, maybe. So that will make that a double as well. Nice to have the precision. Right, so we will accumulate some time into this, and while let's see, while this accumulator is greater than the delta time, right? Then we'll just subtract the delta time from it, and this will be a tick, right? This will be a game tick. So if we are rendering at like 200 frames per second or 100 frames per second, there will be a lot of frames where this condition is not met at all, right? Because this is, well, at 30 FPS this is 35 milliseconds. So if you have frames, if you're rendering frames faster than 35 milliseconds, which I definitely am right now, yeah, like the game will not update, and you will see the exact same thing. You will see the exact same thing every time. So I guess like the only like real thing, like, yeah, the game is the only thing we have to tick, right? The game is the only thing. Yes. Yeah, that's something. And we don't have to pass the delta time now, because that is completely fixed. Right, and this time, what are we actually using this for? What are we using this time for? Is that... We're not using it, apparently. Apparently. Yeah, okay, that's good to know. Let's delete. So, right, yeah, we don't need to pass the delta time. All right, good, and yes, let's try see what happens. And I think the game is probably going to be a lot slower now than... Okay, not really. Well, okay, the camera is extremely slow. Okay, interesting. I guess the interpolation factor is extremely low. So, because I had so many frames before. Hello, where is I'm in the completely wrong place. Right, so we set the camera position here, so we lerp it towards the player by some factor, and this is way too low now with our new tick rate. Okay, that's nice. I assume... Oh, what the... My collision detection is even more wonky now than before. Jesus. Okay, but you can probably see now that this is 30 frames per second. I can at least see that. I can lower it even more, right? I can change this to 10 frames per second. Now the game feels horrible to play. Right, I can make it 60, I think. Right, but like regardless of what the tick rate is, like we're still like the physics still behave the same, right? Well, more or less. Like we're gonna move at the same speed, we're gonna jump the same height, and so on. I hope so, at least. It seems like it. It seems like it. And now... Oh, I guess one slight... one issue with our new wind. Well, it's not like... The wind grid doesn't seem to be doing anything, really. I will check the debug rendering if we can see anything. Yeah, okay, so the velocities are super small now. But why? Why are they super small? Oh, well. Wait. Right, we probably... right, so now we actually have to separate these into some different functions, because we want to tick the wind at the same tick rate, like immediately after the game has finished all the game logic. So, okay, so right now we are ticking this simulation too often, right? So we'll add some tick function to separate that out. And do I actually use this delta time right now? No, I don't think so. Right, so we still... So in this function we do this actual simulation, right? And we also do the uploading of the buffer to the GPU. And this GPU uploading should only happen once, so that should not be like tick bound. That should only be once per frame. So we still want this wind update here, but we want to tick the actual simulation, yeah, here, after the game is done. Right, it still seems to be injecting too little, and I wonder what the difference could be. Could it be this velocity? Like... Let's maybe try to scale it up just a bit, I guess. Scale it up. Okay, now it's oh shit, it's too slow to like to rebound, right? So that factor, and like these percentage values, like decreasing something by a percentage each tick, that's like not nice, right? I want to make it delta time dependent somehow. Because now it's gonna be dependent on the tick rate. Okay, that looks kind of fine. But yeah, these percentage values, because if I have a lower tick rate now, that means that if I'm every tick, I am removing 10% of this velocity. Like, that's gonna be tick rate bound, right? So if I'm ticking less times per second, that's gonna be slower to actually go down to 0, right? So I'm actually not sure how I should use the tick rate to fix that, though. I'm not entirely sure. Okay, but that's working. Right, so I guess one problem was before that, if I tab down the game, there would be a very long delta time, and my player would just fall through the ground. That shouldn't be a problem now. Yeah, no, it's working. It's working. I feel like are these, this factor could be a bit I can make those into constants, right? Maybe or whatever. I feel like it should approach it should be a bit faster to rebound. Okay, but now that I have a fixed time step, it's gonna be much easier to do physics and stuff like that. Because I was thinking about improving this collision detection, so I don't phase through walls. Yeah, that would be nice. And having a fixed time step is kind of a prerequisite to that. I actually want to see what my topology looks like. Yeah, so I'm just walking through this triangle because of the way I do it right now, but if I land on it, yeah, it's fine, right? Yeah. Unacceptable. Right. What should I come up with next? Oh shit. Oh my god. Look at those triangles. That is absolutely horrible. Long, thin triangles. God damn. La 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 la. I'm still leaking objects. Or what is this? What is this? Is this let me see. Is this if I go outside of the wind area? Okay, no. Apparently not. Apparently not. Is it? I assume it's when I run out of if I run out of vertices. So like right now, these flowers, that's actually quite a lot of vertices, right? So if I add a bit more surface, yeah. Yes. I run out. I run out of vertex buffer space. Yeah, so that's kind of a problem, right? Maybe I could look into fixing that. And the way I would fix that, I think, is to do some culling before I actually create these vertices. So primarily, just check if the flower is gonna be outside of the screen, right? And then if it is, then I just don't create the flower, right? And that would be the most basic option here, I feel like. So I would still have maybe some, maybe some like list of positions, like seed positions, something like that, and just check if those are visible before I actually put the flower there. That's probably the best solution. But there's still the worst case, right? Where I'm looking in the editor at literally all of the flowers, right? Then that's not gonna help, right? So yeah, I'm not sure. I should at least have some budget, right? And I should respect that budget when putting out flowers. So I should not be. Yeah, I should at least stay within the budget. I think that's the main problem here. And it would obviously like still flicker and stuff, but yeah. Yeah, I guess for now let's actually see how much memory we are using for this. I did okay, so I think the world basically, this staging buffer, yeah, that contains all triangles, yeah, right now. I'm pretty sure. Yes. I mean that's not a lot. It's 288 kilobytes. 288 kilobytes. So yeah, the limit right now, vertex limit is 16,000. And to a modern GPU, that's nothing. That's nothing. And we can push this to, we can make that 256 limit. Let's see what's that. Yeah, that's 4.5 megabytes, right? It's fuck all. So now I should be able to. Make the world bigger. Yeah, without getting this validation error, right? There's sometimes a random triangle appearing. I think I might know what that is. Yeah, I probably should fix that. I can fix it in the easy way, or the hard way. Let's go with the easy way. So the problem is that I'm filling all of these triangles and the index buffer every frame now. Basically, because I have this editor, right? So if I move these points around, I have to update the vertex data on the GPU, right? So right now I upload that every frame, and the problem is that like we're telling the GPU to copy this data from RAM into VRAM, like on the actual GPU, right? But this copy buffer command, it's just a command. It doesn't happen immediately on the GPU. It happens at some point later, right? So what's basically happening is that while we are like rendering a frame on the CPU, the previous frame is still being processed on the GPU. So what's happening is that we're filling this buffer at the same time as the GPU is reading from this buffer. which is really bad. So we basically have to wait until the GPU has actually finished this copy, right? Because it doesn't happen immediately, right? So the easy way to do this would just we have this frame count, which is how many frames we have in flight at the same time. So so we can just wait that number of frames until we actually do the upload again. So we can just have some kind of like staging counter, let's call it. Staging counter. So we will increment that. Let's think about this. I think we want to pre-increment it, and if we just compare it, no, let's do that. So we have the frame count. If that is the case, we just don't upload. Do not upload, and we reset it here, right? Okay, that's literally it. Problem solved. Problem solved. And now, I guess there might actually be some kind of visible delay here, in theory, but I'm rendering so many frames per second that it's not noticeable. But in theory, there is some delay here when I drag a vertex or whatever, but it's not noticeable, so that's fine. And now I shouldn't be seeing any more strange triangles in the middle of the screen. Let's see, what are our changes? Right, we did the whole fixed tick rate, right? Yes. Fixed tick rate. Well, fixed tick rate. Add fixed tick rate. And bump vertex buffer size. Right. I think that's it, I guess. Yes. This wind is awesome. This wind effect. So, well, one problem with this wind, right, is that the grid is finite and it obviously doesn't work if I walk outside of it. Right? The grass doesn't move, which sucks. So I would ideally want to make this grid follow the player, right? Or follow the camera. I'm not sure which is more preferable. But we want to make sure that it covers the current playing area, right? Maybe I could do that. Maybe I could do that. Maybe I can do that. That shouldn't be too difficult, I feel like. So what do I actually need for that? Do I want to change the origin? Probably not. There shouldn't probably even be an origin. There probably should not be an origin. So, well, I guess we'll start with something. So, we will add. So the grid on this wind system, right? We'll have to know at least where the player is, or where like the focus position should be, right? So we need some way of specifying that. Let's just have a simple wind set focus. Let's do that. Right, okay. So what should actually happen? Like, we don't actually have to rearrange any data inside of the grid, right? We only need to we shit, this is hard to conceptualize. We only have to have some kind of offset, some number of grid cell like offset in each axis that just modifies, just shifts it around a bit, right? Because the grid doesn't have to physically move anywhere, right? We only have to change which cells we are reading and writing to, right? But at least let's. So if we have the focus position, okay. So first step, actually, let's remove this origin. Origin won't be needed anymore. I think so at least. Well, the origin will be it will be an integer vector, right? Instead. Yeah. But I'm wondering what it should mean. I guess we'll figure that out. Because we need some kind of origin at least. But it's not going to be some kind of world space origin. So remove that from the debug rendering. Yeah. Well, okay, I'm gonna have to think really hard about this, but okay, let's just start by so we need to figure out the number of cells to shift all of our operations by. So how is that going to be affected by the focus position, I guess? So something like, I imagine something like, okay, so let's say that we move to the right. Okay, wait, we move to the right. Well, the focus position moves to the right. Okay, let's just do something. Okay, so so we'll take the focus position and we have to snap it to the grid, right? So we know the size of each cell in meters. So if we divide by that, we figure out which cell we should focus on, right? So let's make that. Yeah, that's the meaning of the origin, right? Which cell is the middle, right? Right, that's it. Simple enough. Let's also call this. We will use the player position as the focus right now. Right. That looks fine. Okay, so now what the hell should we actually do with this focus position? Wait. Wait, can't I just... Okay, hold on. I can just... I can just wrap this data. I can just wrap the load and store operations, right? So let's ignore this origin, right? To start with, let's ignore that. And yeah, instead of this, it's not as straightforward right now, so we instead yeah, okay. I should have done this first, actually. Shit, before I started messing up stuff. Wait. Oh. Oh, well, anyway, we can just change the debug drawing first. That's easier anyway. Let's not care about the shader for now. Except for removing that. Okay. All right. So what I'm thinking is that right now we do this bounce checking here. I would say just don't do that, and instead we take this X and the Y and just clamp it. Or not clamp, we wrap it around, right? So we have the resolution and just wrap it around. So the grid is essentially repeating infinitely, right? Essentially. Wrap X. Right, that should be it for the injection part. And the I changed something here, right, in the debug rendering. So I'm thinking how to do this debug rendering then. I mean, we have this origin, and that should be the center. So let's do something like so if we're drawing the vertical lines, we can start. So we have the cell that should be in the center. So let's subtract half of the resolution from that. And go until... Well, okay, Jesus, let's not do that here. Let's just do that in here, right? So we have some other... What should I call this? So we'll take the X value and add the origin, yeah? Minus half of the resolution. This part makes sure that it's in the center, yeah? Let's see what happens. Not what I expected. Right, I have to use this. God. Okay. What? Okay. Okay, let's not care about that. Okay, so it's seemingly going on forever now, right? That is good. That's good. Now what's up with this actual... Well, that's the easy part, right? This is the easy part, and we want to do the exact same with the Y. Yeah, this is definitely the easy part. Debug drawing the actual velocities is going to be a bit more difficult, because then we actually have to use this origin. Oh well, this is so messy, but it's debug code anyway. I think we want to do that. Okay, not quite right. Why is it? So yeah, what's happening? So the horizontal lines. Wait, yeah, these are the horizontal lines, right? Oh, I think I want to do something like this, right? Okay, and I have to... Yeah, okay. Why? Alright, so we have the grid again. That's definitely the easy part. And now we have to place these velocities in the right place. I think at some point... Okay, that's... Apparently it's not the easy part because I fucked it up. Okay, so this grid origin is in grid cell units, right? Okay, so I have to somehow, I guess, multiply this into world space if I want to actually draw it on the screen. Well, I do that here, right? Yeah, okay, with the cell size. So what is the problem? I don't do it here, right? I don't do it here. Okay, is that the only problem? So this is getting out of hand, but I think that will maybe do it. So this is the Yeah, this is the vertical lines. Okay, how can I verify this? I guess it seems to look fine, right? And if I jump down here, okay, at that point it's if I get really far away from the oh well, this doesn't even have to be that accurate, so whatever, as long as we have some grid, okay, it should be fine. Should be fine. Let's actually just swap these. That's gonna be easier than finicking around with moving stuff around. Okay. Okay, so we have some grid that's seemingly centered around the player. Okay, sure. Okay, now okay, what did I actually do with this injection code? So right, the offset is not used in any way here. Does it have to? Well, right, I used the grid origin here. Let's just not do that. Let's not. And so it seems to be reversed somehow. I'm gonna print these. Oh, never mind. Okay, I should just not subtract this. Okay, so we have those working now that are like in the positive quadrant, right? Okay. That's good. Okay, so the only difference now is like we just have to assume some wrapping. So right now we are just, it's just, this should be very easy, right? So yeah, we probably want to make this the reversed way. So we're gonna instead, I think that's gonna make it easier. So we'll instead just loop over the rows and the columns separately. That should should be easier. And then we'll have like this, let's call it dx. So we just want to subtract wind grid resolution. Yeah, subtract half of the resolution, right? In both directions. Well, let's start with that. Yeah. Another problem is that these are negative, right? Or whatever. So we should, when we figure out the index here, so the index is usually, it's dx plus dy times the resolution, right? Yes, but we have to wrap these before we do this. And we want to wrap them to the resolution, right? Like that. Now we should have the cell index here, right? And this center calculation should, that's probably gonna remain the same, right? So we want this D, I don't know what I should call those, but that's basically the, I guess, global cell index in some way. Yeah, so that center should be fine now. And yeah, so now we just have to load this velocity using the index, and it should work. Let's make this const. Looks fine. Okay, looks fine except where it doesn't. What the fuck? Is this index weird? It shouldn't be. Wait. Definitely looks like something. This should be fine, right? Okay, let's I guess debug it. One 25. All right. So what? I should check the index here. Okay, index. Okay, that is completely. The index is negative, but if I, what happens if I do modulo on a negative number? I thought it just. I thought it like works as expected. Apparently not. What? Okay, that blows my mind. A modulo negative integer. I have to investigate this now. Okay, can I somehow get... Can I get the expected behavior? Or the desired behavior? Well, so... Okay, how... Can someone give me what would I even search for? Modulo negative integer. Please, like, please. Okay, they probably. Why can't it just work? I guess if I... Okay, hold up. So if I just... Right, so my resolution, if that is a power of 2, if it is a power of 2, I can just make this a uint, right? Like that. Yeah, but what's wrong with... I don't trust the precedence here. Let's be explicit. All right, so the left works now, right? But when I'm below the y-axis, there's nothing. There is nothing, and I wonder if that's because the injection is failing, right? Or if the debug visualization is failing, right? Oh well, I mean, okay, this would also fail now, right? So I will just do a uint for these as well. Yeah. Yeah. Okay, nice. Okay, nice. Now the only we still have to move this around. Let's actually hide the grid. We only need to see the velocity vectors. Velocity looks a bit sus. Why is it? Oh well. Right. I can scale this up a bit to make it more visible. Yeah, the velocity looks a bit weird. I should really compute that. I think that's because of how the game computes that velocity. Yeah. Anyway. We have to change this. We have to move this a bit more, so we are moving it so that the center of the grid is at the focus, but we also have to move it to the focus position, right? Maybe I should call it focus position actually. Okay, so let's see if this works. If I go... Yeah, that works now. So this grid should be infinite now. Oh, my camera is too slow. Alright, we should really get a better injected velocity, but for now let's try to sample this again now from the shader. So what's wrong now? Right. Can we still do this calculation? No, we actually have to wrap. We have to calculate each position independently. Yeah. Okay. So this will be 0, 0. Yeah. like, wait, if we have a float and cast it to unsigned, I mean, we can do this just to be explicit, right? Because this should be an unsigned. Yeah. So let's see. The top left pixel should be just this, right? Wind wrapped by the resolution. Yeah. Okay, so that's 0 0 1 0. Top left. Well, in reality, bottom left, but in my head, it's top left. Right. That should probably be it, right? What is the problem? Redefinition. Like that. Okay, it's a bit off, right? It's a bit off. Although we can, I think this is a bit cleaner, maybe. So that's still a signed one, and we have to cast that to an unsigned before we do the modulo. So it gives us the expected result. Okay, did that literally fix it? Did it? It looks like it's moving. It seems a bit off though, because these... Yeah, something's definitely a bit strange. Some of these flowers they're just completely still, right? Yeah, there's definitely something wrong with this sampling. If I try, I can make a non-bilinear version, I guess, just to make it simpler to see if the position is right. So for that, like that, and we don't subtract. We just want to know which grid we are inside, right? And then to figure out the index, oh, there should be a, there should be a sign still. Okay, that might be what's wrong actually. Let's see. Did that compile? Yeah. There's definitely something strange. Seems like these top ones aren't really moving, even though this grid cell is definitely injected. Okay, yeah, it looks really strange. So these are wrapped, yeah, so that seems fine. Oh well, let's just try this. So that's gonna be that, and index is gonna be right. Let's make this a unit. No, okay, so that's just gonna be like I can do that here, so sure, okay. Like that. Okay, so no bilinear filtering. That's even more incorrect. It's too far down, but wait, am I doing something completely stupid or what? Move this into the bilinear block. So like this. Oh well, we need the float position, right? We need the float position. So cast this to an int. Well, maybe, I mean, for negative, what actually happens? Which, if it's just truncation, right? Oh, maybe we should floor it. We should probably do floor on that. Because truncating a negative integer, that's gonna actually move it towards 0, right? It looks like it's just offset by some strange, like 3 units or 3. Like, what is this? What? I mean, maybe well, no, the injection isn't wrong, because my debug rendering is working, and assuming that the debug rendering is correct, which yeah, it should be. What could be wrong here? Let's try actually to, so we know where the world origin is. Let's move this up so we can actually test inside of the positive area and see if that's working, because there might be some unexpected yeah, okay, that's working. So it's only the negative area, right? So there's something wrong with my wrapping logic here. But how? Because okay, let's just try some stuff then, I guess. So that's not working, right? Yeah, this is completely fine. Okay, so what the so I'm taking the floating point position, right? Scaling it into the grid cell space, right? So 1 unit equals 1 cell. I'm doing that here. This division, right? I'm gonna take this position and floor it. So I take it down to the next whole number, right? Next whole number. And I did have an int cast before, so I make that into an integer. And then I convert it to an unsigned integer. And assuming my resolution is a power of 2, so it should always be divisible by the maximum value of a uint. So, like, I don't see any problems with this, and like this worked on the CPU, right? I do this exact same thing when I'm filling. So I have this integer grid cell coordinate, which is basically the global grid cell coordinate, right? I convert it to uint, and the wrapping from signed to unsigned should be fine. It should be fine because maybe that behavior is different, I guess. Maybe the wrapping behavior is different on the GPU. That would be very unfortunate. And solvable by just using a texture for this wind data. But can I do anything to Well, okay, let's try something silly. Let's try that. That's working. Okay. All righty. Wait. Yeah, that's working. Okay. I do not care. I do not care. It's working. So. Or is it? This still looks a bit suspicious. There seems to be something. There's something going on with a couple of flowers, and I wonder if I can have a better way of visualizing this, really. I can increase this, but that just looks silly. But it's pretty visible now. Like exactly this. Oh. This flower in specific is like, it's just being stretched. In a very, it doesn't look like it's really working. It's some kind of work. It looks really strange. Is it because of the bilinear? So I should probably first I probably should well, hold on. There is like an how does a floating point modulo work, actually? Is there an fmod intrinsic, or do you just do it? Right, there is an fmod. Floating point remainder, I guess it's the same, right? Yeah, it's definitely gonna be the same, so that doesn't really help me, right? Okay, so let's try with the bilinear filtering again. So now we know what the problem is. So we need, yeah, this integer. We need to add that number, and we need grid resolution. Oh well, no, right, and yeah, let's wait. Is this even? Wait, that shouldn't work, right? Wait. How does that look? All right. Let's do that. I think it doesn't make sense to add that, right? So yeah, we can keep that. We can keep that as a signed. Okay, something is definitely up. Something is wrong. Something is wrong. Did I do the filtering correctly? Well, it still looks. Well, no. It still looks wrong when I don't do that, right? I don't see what could be wrong either, because I mean it's getting the position is correct, right? Position is correct. I think I should change the way that I compute this velocity to inject. So where do I actually tick the player movement here? Yes. This game state is completely useless, at least for now. But all right, so I think the best thing would be to just basically save, I guess, previous player pos. So we'll just save where the player is before doing any calculations, right? Right. And then the velocity will just be where the player currently is. The difference between that, right? So we moved somewhere. Yeah, that's the new velocity. So that should look a lot better and makes. That's gonna be easier. So then we don't have to track the velocity in some way of the player. So let's see. Yeah, just pass this velocity. Right. See, it's probably gonna be a lot. Oh. Oh, now we can see. Now we can see this problem very nicely. Can I, if I zoom in a bit? So we're sliding down very slowly here. Like they're just sampling it in a very strange way, right? I mean, it's gonna be quantized, but inside of these Oh, hold on. Hold up. Hold up. Right, so I'm using the already displaced position. Let's not do that to start off. So, right, there's no procedural wind now. There's only this, and like, I feel like it should be, it should not look this wild, right? Because inside of these, okay, let's try without the bilinear, right? Maybe it is correct. It's just hard to see. It's hard to see. Yeah, we need some better debugging. But like, okay, if the pixel center is here, right? These should definitely be moving. Okay, so something is wrong. But how? Like, okay, let's add back the actual grid. That should make it very easy to see now. That should make it very easy to see. So that's the grid, right? Okay, I mean, yeah, it's definitely wrong, right? Because so this cell is like, yeah, this okay, something is definitely wrong. Definitely. Is it just offsetted by some amount? Seems like there's just some offset, right? It's offset to the right. Offset to the right. Yeah, because, okay, yeah, these are being dragged when... Yeah, okay, so... Yeah, so how... Okay, what's going on? So there's definitely something in the sampling, right? Taking the floor of the float grid pulse. Let's just skip this for now, and let's just assume, and let's do that, and stay in the positive area for now. Okay, that's working. That's working. thought there was still something wrong with my wrapping logic. God. Okay, so if I do... Let's do the... Yeah, let's fucking... skip that shit. Okay, so if I do bilinear now... Up here... Yeah, that seems to be working. Yeah, the center, yeah, pixel center seems to be fine. It's just completely like this negative fucking wrapping shit. It's just like there's got to be some clever way of doing it. Well, yeah. Whatever. I will figure that out at some point. Someday. Let me edit this. I want some more test area up here. So it's definitely working in the positive area. But I have to fix the negative wrapping, right? So now if I do just wrap it now, that should work, right, in the positive quadrant. Yes. And I should tone this down somehow. So let's see what. Right now, I just add the injected velocity on top. Maybe that works if it's scaled down enough. Maybe there should be some threshold, or maybe
my missus left me. I was in love with her. I was destroyed by all of that. You know, if it's happened to you, if you're listening to this, if it's happened to you, then you'll understand what goes on. You're consumed with this sort of universal grief.
oh well.
Your head
Oh well, oh well.
Any way around it? You say, well, you've got to move.
I want to scale that down again.
Find a way around this sort of encoding.
And we can add this now, and yeah, let's add that before, right? And let's move the camera out again. Definitely too much. I like the behavior before. Like if I'm sliding down like at this speed of a snail, right? It shouldn't like get this large. So. I can try. I don't want to assign it, right? But instead of adding, I guess we can try to lerp it towards. So we will lerp the current velocity towards. Oh, I just okay. Okay. Well, how about we just first don't fucking normalize it. Okay. Okay, that should be a lot better now. So let's. Yeah. Okay, that looks pretty good. Pretty good. And we can remove the grid for now. Yeah, am I using Bilinear now? Yes. Yes. I mean, looks cool, right? Yeah. Nice. And what did I do? So this would be basically, I guess, making the grid infinite, right? Basically, and we can remove this now. There is no origin. There is no origin. Right. Remove the grid origin from the constant buffer. Yeah, I really like the effect, though. Even though it doesn't work on the negative axis. Well, it does work. Wait, is the modulo behavior like I expected it to work on the GPU? Okay. So there's no like standard way of doing it or what? Like but that is good. I guess. But unexpected. I had to do a bunch of trickery to get modulo working on negative integers, but GPU just does it like you expect it to work. Nice. Do I have 2 games running? Bruh. Oh shit, my GPU was hung for a while. Yo, what's up, Zig user? I'm not a Zig user, but I really wanna try Zig. C is my favorite language, so I think it would be... It looks really nice, Zig. It does. And yo, I'm trying to... Yeah, make some kind of game, right? We're mostly focusing on rendering right now. So we have this cool kinda wind effect, I guess. Fake wind. So this player bounding box just injects its velocity into a grid, and we upload that to the GPU. And when we draw these flowers, we just sample from that vector grid to offset them. Like, so it looks like the player is like creating drag, right, or creating some kind of vortex, right? I think it looks pretty good. I think it looks good. And I have a level editor that I made. I think, not sure. But you can change this geometry as you wish, right? And save it to a file, and yeah, let's see. It's world.bin, right? Yeah. So this is the save file for the world, right? Yeah, I really should try Sig. Looks like it improves a lot of things. But if you're making a game like error handling and stuff like that, like it's not really that critical in reality, right? So C is fine, and like in terms of, I guess, safety and stuff like that. But I've never really felt the need to use anything other than C, really. For most stuff, it's just the perfect language. I wonder what to do next. So here is the actual vector field, right? That represents this this wind. Ah, that's cool. Cool. Is there anything simple I could do? Maybe. 'Cause it's getting pretty late, so I'm soon gonna get off. You caught me at a bad time and bad timing to start writing in chat. But I'm thinking about maybe uploading these streams to YouTube as well. I'm not sure though. Because apparently you don't get Twitch VODs if you're not, like, I guess, partnered or whatever. So I don't have those. Yeah, I don't know if there's an easy low-hanging fruit for me to fix. I was thinking about something. No, I just feel like jumping around in my grass mindlessly. Yeah, but I have a lot of ideas on, I guess, the long term. I do want to add some kind of parallax background, right? Yeah, or at least some kind of background. Probably a parallax thingy-majingy. And I'm wondering if that should be like designed the same way as this, like basically just by drawing some polygon, right? I feel like that's a cool idea, but we'll see. I think that might be a nice next step, at least for this, because it's getting pretty boring to just have this one layer. I want some kind of background at least. But yeah, we'll see how I'll solve that. Some kind of parallax scrolling, at least. Maybe some actual gameplay. And I obviously have to improve my collision detection, because I can just walk through walls right now. Which is not intended. It's not a feature. But that's what I get for writing the physics myself as well. Alright, but I think that's it for today actually. So let's see. What did I change since my last... Right, I actually fixed the sampling. Because GPU modulo is based and just works as I expected. Yeah, okay, I didn't commit. I haven't committed until we started doing this infinite wind grid, right? So, well, it's a tiling, I guess, tiling wind grid. I guess that's it, basically. Yeah. Tiling wind grid. Right. I should disable the debug rendering. Hello. Yeah. But that's it for today. Anyway, I hope I see you guys later in the next episode. Bye bye.